everybody, welcome to my Tech channel. We are students of GM Institute of Technology from Electronics and Communication Engineering branch. In this video, we will be sharing you the basic concepts of engineering visualization course.
Yes, my topic is about introduction to lines.
I'm Divya, my topic is introduction to solids.
This is Ananya Gobur, my topic is isometric views and projections.
I am Chandrasekhar, my topic is introduction to planes.
I am Hemant Kumardi, my topic is about columns on orthowave projection of planes.
Hey everybody, this is Bhavani. Today I am going to speak about EVN subject. In that mainly the basic thing, that is how the lines should be formed. In that I am going to speak about convention of lines. Convention of lines have different type of lines. In that I am going to explain each and everything. Coming back to my topic, firstly I want to choose continuous thick line. We can observe, see here, it is nothing but a visible outline or a visible edged line. Then next topic is a continuous thin line. We can observe, it is a visible line which has dimension lines, projection lines, leader lines, imaginary line of intersection, outline of revolved sections. Then coming back to continuous thin freehand line. See, we can observe like sinusoidal waves, boundary of limits of partial or interrupted waves. Then continuous thin zigzag lines. These are the long break lines which we use in signal generation. Then coming back to dashed thick line, these are the hidden outlines or hidden edges which are used in hiding the images. Then coming back to dashed thin and chain thin lines, we can see these lines. These are the center lines or lines of symmetries used in trajectories. Then we can observe chain thin thick at ends and changes of direction. When we are drawing a solid, we use these lines, that is cutting of planes. Then coming back to chain thick lines, these are the lines which indicates or surface with special treatment required. Then coming back to chain thin double dashed lines, these are the outlines of adjacent parts, alternate and extreme positions of movable parts, centroid lines and the initial outlines prior of forming. Thank you.
I am Chandrasekhar. My topic is introduction to planes. First of all, what is plane? A plane is a flat surface with negligible thickness. For example, if you take a piece of paper, in this paper we are having a length and breadth, but thickness is very negligible. Now we see how to project the planes on VP and HP inclined to both the surfaces. In planes we consider two conditions, that is, one will be the resting and another is orientation. Resting in the sense whether the plane is resting on HP. Resting in the sense whether the plane is resting on HP or VP. Orientation in the sense whether the plane is resting on edge or side or corner. While solving problem, we will be considering two conditions, that is, one will be the resting and another will be the orientation. Hint. We consider here the hint. Basically, we consider the planes as square, triangle, hexagon, circle. Like this, we will be drawing. First edge rest on HP means, suppose I consider this is a reference line X and Y. Edge rest on HP means I always consider from the left hand side. This is the reference line and here is edge. This is the edge. And another condition, corner rest on HP. This is the HP line and this is the VP line. Vertical plane. Corner rest on VP means this is the corner, this is the corner, this is the corner. I always consider from the left hand side. And another condition is edge rest on HP means this is the horizontal plane, this is the vertical plane, this is the corner, this is the corner. Edge rest on VP means this is the reference line, which is the vertical plane and horizontal plane. This will be the corner, this will be the corner, this will be the corner. I always consider from the left portion of the plane. Corner rest on VP means this will be the vertical plane and this will be the horizontal plane. This will be the corner from left hand side and this will be the corner from the right hand side. Now steps for construction of plane. The step number 1 is assuming initial position whether the plane is rest on HP or VP. The step number 2 is consider surface inclination to HP or VP, and step number 3 is considering edge condition or side condition or corner condition. Next we will see the problems on planes.
Hello everyone, I'm Divya. My topic is Introduction to Solids. As we already know, solids are three-dimensional figures such as sphere, pyramid, prism, cube, cuboid, etc. Let us consider some examples here: sphere, triangle-based pyramid, and prism. Let us consider a pyramid. If it is rest on one of the sides, or edge, then it is called as a triangle face. If it is resting on one of its corner, then it is called as a slant edge. If it is given the solid is resting on slant triangle face, then we need to construct the solid resting on one of the side or edge. If it is given the solid is resting on one of the slant edge, then construct a solid only on resting with these corner positions. These are some examples to construct the solid figures. Thank you.
Hey everybody, this is Ananya Kapoor. I am studying in GM Institute of Technology under Electronics and Communication Engineering branch. Now I'll be taking up the isometric views and projections part for engineering visualization course. Isometric projections, this is a method for visually representing 3D objects into 2Ds in engineering drawings. The word isometric is derived from the language Greek for meaning equal measures. Isometric views are a simple way of representing a three-dimensional object so that the complexities of a shape can be clearly understood. It is a type of graphical projection in which all three dimensions of an object are shown in one view. Orthographic view shows only two dimensions in any particular view. This makes it difficult to interpret them, and only technically trained person can interpret the meaning of these orthographic views. A non-technical person cannot imagine the shape of the object from orthographic projections, whereas isometric projections can be easily understood even by persons without any technical training, because such views shows all the three dimensions of an object in the same way. But isometric projections does not show the true shape and size of any principal surface of an object, and it does not show the hidden portions. Isometric projections are easy to imagine, so they are all normally used. An isometric view of an object can be obtained by choosing the viewing direction such that the angles between the projections of the x, y and z axis are 120 degrees, and an isometric uses a plane grid at 30 degrees from the horizontal line in both directions. The isometric graph can be used to make the kind of drawings. This is called as ISO sheet. And now the first question we are dealing with is a frustum of square pyramid of side 40 mm, base 20 mm, edges and height 60 mm, resting on the center of the top of square block of 60 mm sides and height 20 mm. The base edges of pyramid is parallel to the edges of the square block. Draw the isometric projections of the solids. So let's resolve this question. So firstly we are going to solve the square block. So the square block had to be 60 sides on all the four sides and height 20 mm. So if this is a point I choose 0, 1, 2, 3, 4, 5, 6, and same as the four rest sides. And now join the 4 points. And the height need to be 20 mm. So extend the lines for 20 mm on the four edges. And now join them. So this is the square block we needed. And now coming to the square pyramid, this has to be a frustum. with side 40 mm, base 20 mm and height 60 mm. And now choose 0, 1, 2, 3, 4, 40 mm beside all the points. And now from here 0, 1, 2, 3, 4, 5, 6, 7, 8. Upon this, let's mark 4 points. And now this has to be joined and this to this, forming a square frustum because this is a square pyramid. And join the bottom. And now, because it is an isometric, we need to trim sides. So we usually trim all the system, but on this paper, theoretically we are going to erase the lines that need to be hidden or hidden portion.
Orthographic projection of planes. We know that point is a 0 dimension and line is 1 dimensional figure and plane is a 2 dimensional figure. Have to solve the problem based on the plane surfaces. The problem is like this: a triangular lamina which is an equilateral triangle of 25 mm sides lies with on one of its edges on HP such that the surface of the lamina is inclined to HP is 60 degree on edge which is where rest is inclined to VP at 60 degree. Draw the projection of the lamina in this position. If the triangular lamina is lies on one of its edges on HP means it has to lie on like this. Here this is the sides AB, this is the edge AB and this is the corner C. If it lies on the corner, it lies on this position C, and this is B comma A dash. Here here they mentioned that it is resting on one of its edges, so we have to draw like this. First draw the XY line of unknown length, mark it XY. Above the XY line mark it VP, and below the XY line this is HP. The condition is that the triangular lamina is of about 25 mm. Using ruler and pencil, one box, two box, 2.5 mm sides, and using the pencil and compass measure the line about 2.5 centimeter. Then cut the arc from one point and another point. Thus the triangle is formed. This is the point A, this is the point B, and this is the C. Join these three sides. In the question it is mentioned that it is lies on HP. It means then in the question it is mentioned that in second position it is tilted 60 degree to HP. 60 degree it is, if it is tilted to 60 degree to HP, you have to draw above the XY line 60 degree. Using the protractor measure 60 degree. And using the compass measure the length of ABC. This is A comma B dash, this is C dash. Cut the arc here. This is A comma dash comma B dash, this is C dash. Using the projection lines, triangle. This is point A, this is point B, and this is point C. Here a triangular which is of compressed size is formed. Yes, this is the front view of the first position. This is top view. Then in question is mentioned that the third position of the figure is tilted to VP 60 degree. Now we have to measure 60 degree below the XY line. We have to transfer here also 60 degree, here also 60 degree. Then we have to transfer this whole triangle into this here. So make the point, make whichever we want the point. This is B, and I have to transfer this triangle over here, B to A. This point is A, and this is the A, B to, this is the midpoint of the line BA. Draw the perpendicular line to this tilted line of unknown length, and using the compass cut the arc. Join these 3 points. This is point C, A, B, C. Here we have transferred the whole triangle into this position like this, and now we have to draw the third position of the triangle using the projection lines. Now we have to match the points A comma A dash. This is the point A, B comma B dash, B, and C. This and this combines at this point C. A, B, pause. This is point B. This is the third position of the triangle formed. This is the first position of a triangle. First position. If a person is seeing the object in this position, he can view these 2 points A and C, since this is the first position, and here second position lies over here. Second position, and the third position lies over here. This is the third position. Thus we have to solve the problems on orthographic projection of planes. Thank you.